This video is going to teach you how to balance chemical equations and remind you a little bit about the law of conservation of mass and the anatomy of a chemical equation. Before we talk about the law of conservation of mass, we need to look at the anatomy of a chemical equation, which basically is another way of saying how the chemical equation looks and what the parts are called. So, first part is there's ingredients. So ingredients are this side over here before the arrow. And the ingredients, the chemistry word we use for that is reactants. Basically, the reactants are what we're starting with before the reaction. On the other side of the arrow, we have what we call the products, which are just the results of the reaction, what were made during the reaction. Now, there's a couple other terms that we need to make sure we know. One of them down here is coefficient. And here's how you spell that. I know the C got cut off, but it's coefficient, just like this. And the coefficient tells you how many there are of that molecule. So if we look right here at this coefficient, this big number 2, that 2 is telling you that there are 2 H2 molecules. Then there's a plus sign, so plus means that it's reacting with something else. So here this is saying there's 2 H2 molecules reacting with 1 O2 molecule. Because there's no coefficient here, we just assume that it's 1. Now when we look at our arrow here, our arrow means yields or produces. So the arrow is saying this is where the chemical reaction happens, and it's going to produce our products, which are over here on the other side of the arrow. So looking at the products, it's saying that the products in this reaction are 2 H2O molecules. We got that coefficient 2, H2O. So that's the molecule that's being produced. Now one more thing that you need to look at, it's kind of hard to see on this one because the numbers all look like they're the same size, but in an actual equation they're not. So I'm going to rewrite it real quick. Okay, so I know my handwriting's messy, but really over here, this 2H2O, it should look like this, 2H2. And see how that 2 is littler? We call that a subscript. It's smaller and it's kind of below where the line of the letter is. So this one's a subscript also, this O2. And over here on H2O, the little 2 on the H is a subscript. And the subscript is telling you the number of atoms that are present per molecule. So if we look at H2O here, it's saying that there's 2 hydrogens, and there's nothing here, so we assume it's 1 oxygen in the H2O molecule. That's what the subscripts tell you. Alright, I know all those coefficients and subscripts can get confusing, so we're just going to go through this quick learning check to see if we can figure out how many atoms of each element are in the following molecules. So if we look at the first one, H2SO4, and I've written it out with the numbers the right size. So if we look at how many hydrogens are in that molecule, so there's 2, because we have that little subscript 2 hydrogens. Then we look at how many sulfurs. There's 1 sulfur, so there's no subscript. Then for oxygens, there's 4 oxygens. That makes sense. Okay, then if we look at the second one, this one's a little trickier. For calcium, we've got 1. For oxygen, this is kind of like algebra. If you have parentheses like this, that means that whatever's outside of them, so in this case the little 2, goes to everything in the parentheses. So this is actually O. There's 2 of them, because that little 2 outside the parentheses. And that 2 also goes to the H inside the parentheses. So in this one, it's got 1 calcium, 2 oxygens, and 2 hydrogens. Okay, and then let's look at the last one, our 3 H2O. So it's 3 coefficient H2 subscript O. So we've got 2 hydrogens per molecule here. But then we've got 3 molecules. So you multiply 3 times 2, and that would give you 6 hydrogens. Okay, then we look at our O. Got 1 O per molecule, 3 molecules, so 1 times 3 is 3 oxygens. Oh, and I actually skipped number 3, sorry. So number 3 is pretty easy, right? 1 Na, 1 Cl. That's it. Straightforward. Alright, now that we know what's what in the equation, let's go ahead and try to balance a chemical equation. So basically what you're going to do is you're going to look at the equation on each side of the arrow. So what I like to do is divide it with a line down the middle of the arrow. So you're going to look on the reactant side and the product side, and you're going to make sure that each side has the same number of each element because it has to follow the law of conservation of mass. So what you can do now is go ahead and pick one of the elements to start with. So I'm just going to start with the first one, which is Zn, zinc. So on the reactant side, I know I have 1 Zn, and on the product side, I also have 1 Zn. So right now those are balanced, 1 and 1. Okay, now let's go ahead and move on to the H. So our H hydrogen on the reactant side we have 1, and on the product side we have 2. So those are not balanced right now. So the only thing that you can change is coefficients. You can't change these little subscripts down here. So what I can do to make this balance is I can put a big coefficient 2 in front of this H. So that would mean now we have 2 H's on the reactant side and 2 H's on the product side. I didn't change any of the little numbers, the subscripts. All I changed was this coefficient here. Okay, so we know we have 1 zinc on each side, and then we have 2 hydrogens on each side. So now we got to look at the last element that we haven't looked at, which is the Cl, the chlorine. So on this side now we have 2, because remember that coefficient 2 goes to both things after it. So 2 Cl's on this side, and then on this other side we have 2 Cl's because this Cl has the little subscript 2. So 2 Cl's here. So those are actually balanced. So if you want to go back and double check, your zincs, on this side you've got 1. Your hydrogens, you've got 2. Chlorines, you have 2. Okay, let's look on the product side. Zinc, we have 1. Chlorine, we have 2. And hydrogen, we have 2. So are those equal? Yes, they are. So that one does support the law of conservation of mass now, which means it is balanced. And that's what you're going to want to do with all of these, is add coefficients in, like what we did here, to make the equation balanced. Alright, now that you know how it's done, let's try another one. So sometimes what I like to do to remind myself that I'm only changing the coefficients is put little blanks in front of each molecule in the formula. So for each one I know I can put something there. Remember, you can't change anything about the formula or the little numbers, the subscripts. So let's go ahead and take a look. I'll draw my line down the middle. We'll look at copper first, which is Cu. So I have 1 on the reactant side, 1 on the product side. So right now those are balanced, 1 and 1. Since they're balanced, we can move on to the next one. Right now we will look at Ag, our silver. There's 1 here, and there's 1 here on the products. So right now those are balanced also. Keep going on. This one is a little bit tricky, but there's an easy way to do it, so I'll teach you the trick. This NO3, it's nitrogen and 3 oxygens, but it's also the polyatomic ion nitrate that you can see on the back of your periodic table if you look in that polyatomic ion chart. So what we can do with this one, since NO3 is a polyatomic ion, it's easier to look at the whole thing together. So instead of just look for nitrogen on the other side, I'm going to look for all of NO3 and see if that's there. So when I look on the product side, I see there is NO3 altogether here. It's in the parentheses, but it has this 2 outside, meaning there's 2 nitrate NO3 molecules over here. So to make 2 over here, the only place I can change numbers is right here where the coefficient is. So I'm going to have to put a big 2 as the coefficient in front of here, so that this nitrate, that NO3, there's 2 of them. If you want to double check, you can always break it down by element again. So if we look at N's, there's 2 N's, and if we look at O's, There's 6 O's. 2 times 3 is 6. We multiply those together. And then on this side, same thing. The N, there's 2, because that's subscript 2 that goes to everything in the parentheses. And the O's, there is 6. 3 times 2, 6. So you can see that those are balanced. Okay, here's the part that messes people up. Now we got to go back because we changed the coefficient here. We changed that to make our nitrates balanced. But what we also did is we changed the AG. So now we have 2 AGs on the reactant side. So now we need to go back over to the product side and make sure our AG is still balanced. So we have 2 on the reactants, so that means we're going to have to put a big 2 over here in the products. So now we've got 2 AGs on the products, 2 AGs on the reactants. Okay, just go back and double check. Our coppers are still good, 1 and 1. So if you want to write that on there, you can, just to make sure. Does everything check out? Is it all equal? Yes, it is. So that means it's balanced, and that one is good to go. If you want to rewrite the equation so it's a little more neat, what you can do is you can either leave these blanks blank, or what you can do is that you can fill in the blanks with 1s. Remember, if there's nothing there, you just assume that that's 1. So if I were to rewrite this, your equation should look like this. And remember, the 1s, the coefficients that are 1s, you don't have to have those unless you want. So if you wanted to erase those, you could. Alright, let's look at one more example together. So this one we've got aluminum oxide, and it's forming aluminum and oxygen gas. So on this, draw my line, and then I'm going to go ahead and start counting up the atoms on each side. So I can see already there's a problem here because with my aluminum there's 2 on the reactants and only 1 on the products. So I can put a 2 coefficient in front of the product 1, and then I'll have 2 on each side. Alright, now I look at my oxygens, and I've got 3 on the reactants and 2 on the products. So this one is kind of a little bit tricky. So what I need to think about is how do I get the 3 and the 2 to end up as the same number? So what I'm going to have to do is multiply each of those by a different number to get the same number. So what I can do is I can multiply this one on the reactant side by 2 by putting a 2 here. So that would give me a total of 2 times 3, which is 6 oxygens. And then this one that's 2, I can multiply by 3, and that would give me a total of 6 oxygens. So you just do something like that so that it will equal out to being the same number on each side. With 2 and 3, it's usually easy. You just do the one that's 3 times 2 and the one that's 2 times 3, and it equals out to 6. Alright, now we got to go back and look at aluminums again because we changed the coefficient here. So now we have on this side 4 aluminums total, because 2 times 2. And then on this side we only have 2, but we wrote that coefficient so we can rewrite it. And we can just make it 4. So I'm going to rewrite this real quick because it looks like a huge mess now. Alright, so rewritten, less messy, it's going to be 2Al2O3, which produces or yields 4 ALs and 3 O2s. So when we look at this, we can double check. We've got 4 aluminums here, 4 here, got 6 oxygens here, 6 oxygens here. So this one is equal, and it is all balanced.